Good morning, afternoon, everyone. Today, we are going to engage in one of the most fascinating thought experiments in modern science. For centuries, we have known, through mathematics, lunar eclipses, and eventually spaceflight, that we live on an oblate spheroid. But for a moment, let's entertain the impossible. Let's pretend that flat earthers were right. First stop, the edge of the world, a colossal, unguarded waterfall into the infinite abyss. Why has no one ever documented this? And let's not forget the miniature, spotlight sun. How does it magically turn day into night without any physical obstruction? Luckily, we don't have to live in that complicated world. Our blue marble is simple, elegant, and perfectly spherical. Imagine the Earth not as a marble, but as a giant, floating pancake. A disk with the North Pole at the center and a massive 150-foot wall of ice, Antarctica, encircling the entire rim. At first glance, it sounds like a fantasy novel. But if we apply the rigid laws of physics to this model, we find that life on a flat Earth would be a chaotic, short-lived nightmare. First, gravity. On a disk, it would pull everything towards the center. This would make the oceans pool at the North Pole and create a gradual slope of land towards the edge. The sun's path would create extreme weather. The center would be a blazing desert, while the outer regions would be locked in a frozen, dark wasteland. Seasons as we know them wouldn't exist, and that ice wall, it would need to be perfectly uniform and impossibly strong to hold back the world's oceans. A single crack would cause a catastrophic flood of cosmic proportions. Thankfully, our planet isn't a pancake. It's a magnificent, self-sustaining sphere, perfectly balanced by the laws of physics that allow us all to thrive.
The first and most immediate problem is gravity. In a spherical world, gravity pulls everything toward the center of mass. Since the Earth is a sphere, that center is directly beneath your feet, no matter where you stand. Down is always down. On a flat disk, the center of mass is the North Pole, but as you walk toward the edge, the center of mass is no longer directly below you. It is increasingly behind you, tugging you back. This is just one of many reasons why a flat Earth is physically impossible.
Scientifically, this would create a climbing effect. Walking toward the edge of the world would feel like walking up an increasingly steep mountain. Even though the ground is perfectly flat, the gravitational vector would be pulling you at an angle. By the time you reach the ice wall at the edge, gravity would be pulling you almost horizontally back toward the center. You wouldn't fall off the edge. You would be pinned against it, unable to move. This has a devastating effect on nature. Water, which always seeks the lowest gravitational potential, would be sucked toward the center. All the world's oceans would gather in a massive, towering bulge in the middle of the disk, leaving the edges of the Earth as a parched, airless desert. Furthermore, trees would grow diagonally, leaning toward the North Pole to align themselves with pull of gravity.
Next, let's look at the sky. In the standard flat Earth model, the sun doesn't set. It circles above the disk like a spotlight. If this were true, we would lose the concept of a sunset. On a sphere, the sun disappears behind the curvature of the Earth. On a flat plane, the sun would simply get smaller and smaller as it moved away, but it would always stay visible to the naked eye. We would live in perpetual twilight, never truly experiencing the darkness of night.
But there's a more dangerous problem: the size of the sun. For the sun to circle above a flat Earth without burning the entire surface to a crisp, it would have to be much smaller and much closer, perhaps only 3,000 miles away. However, if the sun were that small, it wouldn't have enough mass to sustain nuclear fusion. It wouldn't be a star, it would be a cold rock.
Furthermore, the change of seasons would vanish. Seasons are caused by the 23.5-degree tilt of the Earth's axis as it orbits the sun. On a flat disk, there is no tilt. There would be no winter, no spring, no autumn. The climate would be a static, unchanging belt of heat or cold, leading to massive failures in global agriculture and the extinction of migratory species.
Perhaps the most terrifying scientific consequence of a flat Earth involves what we cannot see, the geomagnetic field. Our Earth has a molten, rotating iron core. This geodynamo creates a massive magnetic shield that protects us from solar radiation. On a flat Earth, you cannot have a rotating spherical core. Without that core, the magnetic field disappears.
Without our shield, the Earth would be defenseless against the solar wind. This stream of high-energy particles from the Sun would strip away our atmosphere over time, just as it did to Mars. But long before the air ran out, the radiation would kill us. Cosmic rays would bombard our bodies, leading to a massive spike in cancers and DNA damage. The beautiful northern lights would no longer be a light show. They would be a sign that the very air we breathe is being ionized and destroyed. Without the protection of the magnetosphere, the oceans would begin to boil away into space, and the planet would become a sterile radioactive rock.
Let's move from the theoretical to the practical. If you woke up today and the Earth was flat, your modern life would cease to function within seconds. The most obvious victim is the Global Positioning System, GPS. GPS relies on a constellation of satellites orbiting a sphere. These satellites use relativity and precise timing to calculate your position. In a flat Earth model, satellites cannot orbit. They would simply fall into the center of the disk or drift away. Without satellites, there is no GPS, no synchronized global banking, and no high-speed internet as we know it.
International travel would also become a logistical nightmare. On a sphere, the shortest distance between 2 points is a great circle route. On a flat map, these distances are distorted. A flight from Australia to South America, which takes about 12 to 14 hours today, would take over 30 hours on a flat Earth, because the southern continents are pushed so far apart on the disk.
The only bright side, on a flat Earth, light travels in a straight line without a curve to block it. In theory, with a powerful enough pair of binoculars, someone standing in New York could see the top of the Burj Khalifa in Dubai. But because of atmospheric haze and the sheer distance, you'd likely see nothing but a blurry blue fog.
Finally, we must ask, why isn't the Earth flat? The answer is hydrostatic equilibrium. In physics, once an object reaches a certain mass, around 600 kilometers in diameter, its own gravity becomes so strong that it overcomes the structural strength of the rock. It pulls everything inward as tightly as possible. The only shape that satisfies this all sides pulling inward rule is sphere. If you were to somehow construct a flat Earth out of steel and rock, the laws of physics would immediately go to work to destroy it. The edges of the disk would start to crumble and collapse toward the center. The pancake would literally fold in on itself, accompanied by earthquakes and volcanic eruptions of unimaginable scale, until it became a sphere once again. Nature simply does not allow large objects to stay flat.
What if the Earth were flat? It's a tempting thought, but have you ever wondered what that would actually mean for life as we know it? First, our atmosphere. On a sphere, gravity pulls air evenly around the planet. A flat Earth? The air would simply drift off into space, leaving us breathless. Then there are the seasons. The consistent, life-giving rhythm of summer, autumn, winter, and spring is only possible because our world is a tilted sphere. From our protective magnetic shield to the predictable pull of gravity, the Earth's curve isn't just a fact. It's the very reason we exist. A perfect balance for life.